class today about chemical bonding. Today we are going to study about a new type of bond called coordinate bond or dative bond or semi-polar bond. Okay, let us consider the formation of ozone. Ozone means you know that the molecular formula of ozone is O3. That means it is made up of 3 oxygen atoms. Okay, we can consider 3 oxygen atoms. And what is the number of valence electrons in case of oxygen? Every oxygen atom possesses 6 valence electrons. So let us represent 6 valence electrons of each oxygen atom. Okay, the first oxygen possesses 6 valence electrons. The same way second one, second as well as third one also possesses 6 valence electrons. Okay, let me mark the oxygen atoms as 1, 2 and 3. That is, this is first one and this is the first 6 oxygen electrons of first oxygen atom, and second oxygen atom which consists of again 6 valence electrons, 2, 4, 6, and third oxygen atom again the 6 valence electron of this oxygen atom. You know children, we are studying about a type of covalent bond. So here the first oxygen atom shares 2 electrons from the second one and completes its octet. The same way second one also shares 2 electrons from the first one and complete the octet. Now both of them are not interested in sharing since they are stable. But what about third oxygen atom? The third oxygen atom is in need of a pair of electrons. And in this case children, the second oxygen atom is ready to share electron, but it is not interested in sharing it back. So this type of covalent bond in which only one atom is involved in sharing. In this case only third atom is taking or sharing 2 electrons from second one, but second one is not sharing. That means there is no mutual sharing going on. Is it clear? So this type of covalent bond in which only one atom is involved in sharing is termed as coordinate bond. Is it clear? This is what is coordinate bond. We can represent it by an arrow. Okay, coordinate bond can be represented by an arrow pointing towards the acceptor. Here this second oxygen atom has given us 2 electrons for sharing process, and the third oxygen atom shares 2 electrons from the second atom. So the second oxygen is termed as donor atom since it donates a pair of electrons, and the third atom accepts a pair of electrons which is termed as acceptor. Is it clear children? So the type of covalent bond in which only one atom is involved in sharing is termed as coordinate bond or semi-polar bond or dative bond. Is it clear? The type of covalent bond in which only one atom is involved in sharing is termed as coordinate bond or dative bond. Let us explain another example. Just consider the formation of sulfur dioxide. Okay, in this case we can say that the sulfur atom at the center we can mention and 2 oxygen atom. Here also you know that the valence electron in case of sulfur as well as oxygen both are 6. So let us consider 2 electrons of this particular oxygen, and here also we can consider 2 electrons, and this is for sulfur. Okay children, now if you consider this is first oxygen and second oxygen. To attain stability, the first oxygen shares 2 electrons from sulfur and sulfur shares 2 electrons from oxygen. So here you can see that both of them are stable. Now only the second oxygen is in need of a pair of electrons. So second one shares a pair of electrons from sulfur atom, but there is no mutual sharing going on. Again this particular bond is termed as coordinate bond. Between first sulfur and between first oxygen and sulfur, you can see the presence of a double bond, but between second oxygen and sulfur, it is again a coordinate bond. Is it clear? So this type of covalent bond in which only one atom is involved in sharing is termed as coordinate bond or semi accepts a pair of electron is termed as acceptor. Coordinate bond is represented by an arrow pointing towards the acceptor from the donor. Is it clear? So let us study the next topic now. Lewis representation of simple molecules and polyatomic ions. Okay, we are going to study about Lewis representation of simple molecules and polyatomic ions. Means last class we have studied, in the first class of this you have studied about the Lewis plot structure. Now we are going to explain Lewis representation, Lewis formula, to explain the structure of simple molecules and polyatomic ions. Children, here we are supposed to follow certain rules. The first point is that calculate the valence electrons or total number of valence electrons of the atoms involved in this particular structure. Okay, the first step is calculate total number of valence electrons involved in this particular structure. Involved. Is it clear? What is the first step? Calculate total number of valence electrons involved in this particular structure. Second one, suppose if it is an anion, you are supposed to add that number of negative charge, and if it is a cation, you are supposed to subtract the number of positive charge. Is it clear? If it is an anion, to the total number of charges you are supposed to add that charges, and if it is a cation, you are supposed to subtract the total charges, positive charge, from the total number of valence electron. Now the third point, arrange different atoms in such a way that the least electronegative atom should come in the center. Arrange different atoms in such a way that the least electronegative atom should come in the center. Okay, this is the third point. After calculating the total number of valence electrons, you have to arrange different atoms in such a way that the least electronegative atom should come in the center. The fourth point is that connect all other atoms through single bonds to the central atom. Connect all other atoms through single bonds to the central atom. Then you distribute the rest electrons so that every atom should attain octet. Then the last step is that then distribute the rest electrons so that every atom should attain octet. Every atom should attain octet. Is it clear, children? These are the different rules you should follow in order to write the Lewis representation. I will repeat the rules. The first point is that calculate total number of valence electrons involved. And suppose if it is an anion, add the negative charges to the total number, and if it is a cation, subtract the positive charges from the total number. Then the next point, you are supposed to keep the least electronegative atom in the center. Okay, when you are arranging the different atoms, keep the least electronegative atom in the center and then arrange the rest atoms. Then we have to connect all other atoms to the central atom through single bonds. Okay, connect all other atoms to the central atom through single bond, and then finally whatever be the rest electrons you have, you are supposed to distribute it in such a way that every atom should attain octet. Is it clear, children? Let us see some examples on this basis. First, let us consider the structure of carbon monoxide. Okay, represent the molecule carbon monoxide with the help of Lewis dot structure. First, as the first step, let us calculate total valence electrons. Okay, you know that carbon, since it belongs to 14th group, the electronic configuration of carbon is 2,4, or it has 4 valence electrons. And oxygen belongs to 16th group, so it possesses 6 valence electrons. So total number of electrons we have 10. Okay, now you have to arrange them, carbon and oxygen. Okay, first step, again the next step is join these two atoms by a single bond. Join to these two atoms by a single bond, and then we have to distribute the rest electrons. Now single bond means only 2 electrons are involved. Rest 8 electrons you have to distribute it in such a way that both the atoms should attain octet. So let us give here 2 electrons, 2 electrons. So 4 plus 2, 6 over. And now let us consider here 2 more bonds. So now just see 2, 4, 6, 8 and 10. So that is how we are given all the 10 electrons, and you can see that both the atoms attain octet. Is it clear, children? So first we calculate the total number of electrons, then we arrange the atoms, then you have to first connect it by a single bond and then distribute the electrons so that both of them should attain octet. Is it clear? Let us continue with this Lewis representation with the help of another example. This time let us explain the structure of carbonate radical. Okay, in this case this compound, this polyatomic ion is made up of 1 carbon and 3 oxygen atom. So the total number of valence electrons is equals to 4 plus 6 into 3 plus 2. 4 is the valence electron of carbon and 6 for each oxygen atom. Since we are having 3 oxygen atom, it is 6 3s are and 2 negative charge. So the total number of electrons is equals to 24. Is it clear? Now the next step is to arrange these atoms in such a way that the least electronegative atom should come in the center. Since out of these 4 atoms, carbon is the least electronegative, so we can arrange carbon in the center and 3 oxygen atom in 3 corners. Okay, this step is also clear. Now the next step is to join them with the help of single bond. Okay, after arranging the atoms, you are supposed to join the other atoms to the central atom with the help of single bond and then satisfy the valency, that is the 8 electrons, octet of every atom. So let us satisfy 2, 4, 6 plus 2. First oxygen atom is stable. Second one again you consider 2, 4, 6 plus 2, again 8, that is also stable. Third oxygen atom 2, 4, 6, third is also stable. So we can see that 6 3s are 18, already we have used 18 electrons, plus 2, 20, 22, 24. We don't have any excess electron now, as well as our carbon is not stable, it doesn't attain octet configuration. Then what we are supposed to do, from any one of the atom you can share 2 electrons to carbon. Now just see, carbon as well as this particular oxygen, both of them are stable. Carbon possesses 2, 4, 6 and 8 electrons, and this oxygen also has 2, 4, 6 and 8. So all of them are stable. Therefore we can consider that this is the structure of carbonate radical. Is it clear, children? So what we have done first, we have calculated the total number of valence electrons, then arrange the atoms in such a way that the least electronegative atom should come in the center, then connect other atoms with the help of single bond and then distribute the electrons in such a way that every atom should attain stability or attain octet. Is it clear? Let me give you one more example. Let us consider the formation of NF3. Okay. So the first step, you know that you are supposed to calculate valence electrons. Nitrogen belongs to 15th group, so the outermost valence electron is 5. Fluorine belongs to 17th group, so so the number of valence electron is 7. That is 3 sevens are 21. So the total number of valence electron is equals to 26. Okay. Now the next step is to arrange these atoms, in which you know that nitrogen is least electronegative compared to fluorine atoms. Okay. We have arranged them and connect them with the help of single bonds. Clear? Now you are having, just satisfy their octet. So the first fluorine atom 2, 4, 6 plus 2, 8, it is stable. 2, 4, 6 plus 2, that is also stable. And the last one 2, 4 and 6. Last is also stable. So here you can see that again 6 3s are 18, 20, 22, 24. We are having 26 electrons and used only 24. So that 2 electrons again you can give it as the only for nitrogen. Is it clear, children? Now your structure is complete. Is it clear? This is how we can represent Lewis representation for simple molecules as well as polyatomic ions. Is it clear? The method is very simple. Okay. Now let us consider the limitations of Lewis formula or Lewis structure. The next topic we are going to study about the limitations of Lewis structure. Here as the first limitation we can say that Lewis dot structure always gives importance about octet. Is it clear? Since repeatedly we are telling that every atom has a tendency to get 8 electrons in the outermost shell. So the first limitation of Lewis formula is that it is unable to explain the formation of electron deficient molecules. It is unable to explain the formation of electron deficient molecules. Is it clear? Electron deficient molecules. That is, you know children, for example, you consider BeCl2. Okay, beryllium, you know that since it belongs to second group, it has only 2 electrons and maximum it will be sharing 1 electron from each chlorine atom. That means it is not stable or it is not attaining octet according to Lewis structure. So Lewis structure was unable to explain the formation of electron deficient compounds like BeCl2, BF3, AlCl3, etc. Second one, we can say that again it is unable to explain the formation of superoctet molecules. Superoctet molecules. That is, for example, you consider PCl5. You know that phosphorus belongs to 15th group, so it possesses 5 valence electrons. 5 plus 5 it is sharing from each chlorine atom. That means it is exceeding that octet. So this type of compound formation also Lewis was unable to explain. Third one, we know that, children, we know that 18th group element possesses 8 electrons in their outermost shell. So xenon, which is an element from 18th group, already has 8 electrons. Still it forms the compounds like XeF2, XeF4, XeF6, XeOF2. There are so many compounds of xenon. Even Lewis structure was unable to explain the formation of xenon compounds. The next one, we can say that Lewis structure was unable to explain the formation of odd number of molecules with the odd number of electrons. It's not able to explain the formation of molecule with odd number of electrons. For example, if you consider NO, this structure Lewis was not able to explain. And even we can say that Lewis was unable to predict the changes which takes place during, that is the energy changes takes place during bond formation. Is it clear, children? That are the drawbacks of or limitations of Lewis structure. So the first one is that Lewis structure was unable to explain the formation of electron deficient molecules. It was not able to explain the formation of superoctet molecule. Lewis molecules which contain odd number of electrons. And the last limitation we can say that it is unable to predict the energy changes which takes place during bond formation. Is it clear, children? That is about the limitations of Lewis structure. The next topic we have to study is about formal charge. Formal charge means it is the charge assigned to an atom, or it is the difference between the number of electrons possessed by an isolated atom and the number of electrons assigned to an atom in the Lewis dot structure. Is it clear? Formal charge is defined as the difference between the charge, or the difference between the number of electrons of an isolated atom and the number of electrons assigned to an atom according to Lewis dot structure. We can calculate formal charge by different formulas. So the first one, you see, formal charge is equals to total number of valence electrons minus 1 by 2 into shared number of electrons minus number of unshared electrons. Shared electrons are otherwise termed as bond pair of electrons. Bond pair, that means out of valence electrons, the electrons which are involved in bonding are termed as shared electrons or bond pair of electrons, and in valence electrons, electrons which are not involved in bonding are termed as unshared electrons or lone pair of electrons. Is it clear, children? So we have seen that formal charge is equals to total number of valence electrons of a particular atom minus 1 by 2 into shared number of electrons minus number of unshared electrons. Now using this formula, let us calculate the formal charge of different atoms in ozone. Children, in last class already I explained you how to draw the Lewis structure. So first let us draw the Lewis structure for ozone molecule. Okay, we have drawn the Lewis structure. Now just see, let us mark the oxygen atom as 1, 2 and 3. First we will calculate the formal charge of each oxygen atom on the basis of this formula. So let us see, formal charge of first oxygen is equals to, you know that the valence electron for oxygen is equals to 6 minus 1 by 2 into number of shared electrons. You can see that 2 plus 2, 4 electrons are shared over there. So 1 by 2 into 4 minus number of unshared electrons, that is again you can see the presence of 1, 2, 3, 4 lone electrons are there, so minus 4. So this is again 2 and 4 get cancelled, it comes 2, so 6 minus 6 is equals to 0. So the formal charge of first oxygen you got it as 0. Now let us calculate formal charge of second oxygen. Again number of valence electrons, you know it is 6 minus 1 by 2 into number of shared electrons. 2, 4 plus 2, 6 minus number of unshared electrons. You are having only 2 electrons at the top, so it is minus 2. Again children, you will get 6 minus 5. 6 and 2 get cancelled, so it is 6 minus 5 which is equals to 1. Now the third case we can consider formal charge of third oxygen. Okay, third oxygen, apply the same formula. Number of valence electron will be 6 minus 1 by 2 into number of shared electrons. Only 2 electrons, that is 1 by 2 into 2 minus number of unshared electron is equals to 6. So this time the formal charge you got it as minus 1. Now just see children, for the whole molecule if you consider, the formal charge you are getting it as 0. Is it clear children how to calculate the formal charge on this basis? So we have seen that formal charge is equals to total number of valence electrons minus 1 by 2 into shared number of electrons minus number of unshared electrons. Now let me explain it with the help of another formula. We can consider the same case, same example, but just make a slight change in the formula. We can say that formal charge is also equals to valence electrons minus B minus D, where B stands for the bonds and D stands for the lone number of electrons. B valence electrons minus number of bonds minus number of lone pair of electrons. Okay, again you consider the same example, ozone. So this is the Lewis representation of ozone. Let us consider the same example, and this case also let us calculate the formal charge of each oxygen atom. The first one, formal charge of first oxygen equals to number of valence electrons, you know that it is 6, minus number of bonds. How many bonds are here, children? 2, minus number of lone electrons, 1, 2, 3 and 4. So you got the formal charge of first oxygen again as 0. Now let us check for second oxygen. Formal charge of second oxygen is equals to, again valence electron is 6, minus number of bonds 1, 2, 3, minus number of lone pair is 2. So you got the formal charge of second oxygen as 1. And let us see the formal charge of third oxygen. Again number of valence electron is 6, minus number of bonds is equals to 1 and number of lone pair of electron is equals to 6. So you got the formal charge as minus 1. Is it clear, children? So you have seen that in both the ways we are getting the formal charge as same. So whichever formula is easier for you, you can apply that particular formula. Is it clear what is formal charge and how to calculate formal charge? And here we can see that the main advantage of formal charge is that it helps us to find out the stability of the molecule. Okay, the advantage of formal charge is that it helps us to find out the stability of the molecule. The structure in which the atom possesses the least charge is considered as having least energy and hence maximum stable. Is it clear? So formal charge helps us to calculate the stability of the molecule. Okay. Now next topic we have to study about the explanation of VSEPR theory, that is valence shell electron pair repulsion theory. Is it clear? So can we start with the next topics, children? Okay, let us consider VSEPR theory. VSEPR theory is otherwise called valence shell electron pair repulsion series. That is, this is the short form of that. Valence shell electron pair repulsion theory. This is the theory actually we are going to explain at first. It explains the geometry and the shape of the molecule. Is it clear? This is the first theory which is used to explain the geometry and the shape of the molecule. First, let us pass through the postulates of this theory. According to this theory, the first postulate is that the geometry and the shape of the molecule is decided by electrons in the outermost shell. That is, it is the geometry and the shape of the molecule is decided by the valence electrons of the central metal atom. Okay, geometry and shape of molecule is decided by valence electron of central metal atom. Is it clear, children? That means if you just consider any compound, central metal atom. That means if you just consider, suppose carbonate. So carbonate, the central metal atom, the central element, we can say that it is carbon. So that will be deciding the geometry and the shape of the molecule. Okay, geometry and the shape of the molecule is decided by the central atom. Okay, valence electron of the central atom. Now we can consider that second point. That is, these electrons which are placed around the central atom repel one another since they all carry negative charge. These electron cloud repel each other, repel one another since they carry negative charge. Since they carry negative charge. geometry and the shape of the molecule is decided by the valence electron of the central atom. Second, we consider that the electron cloud repel one another since they carry negative charge. Third point is that these electrons are placed in such a way that the repulsion should be minimum. The electrons are placed in such a way that the repulsion should be minimum. Is it clear, children? Third postulate is that the electrons are placed in such a way that the repulsion should be minimum. And the last postulate is that this repulsion varies. We can say that lone pair repulsion is stronger than lone pair repulsion, which is stronger than bond pair repulsion. Is it clear? Already we have studied about the types of electron pairs. You know that what is lone pair and bond pair. So lone pair repulsion is stronger than lone pair bond pair repulsion, which is stronger than bond pair repulsion. Is it clear? Let me tell the postulates once again. The geometry and the shape of the molecule is decided by the valence electrons of the central atom. The electron clouds are that is which placed around the central metal atom repel one another since they carry same charge, negative charge. In order to minimize repulsion, they should be placed in such a way that the distance should be maximum. The magnitude of repulsive interaction varies in this way. Lone pair repulsion is stronger than lone pair bond pair repulsion, which is stronger than bond pair repulsion. The explanation of this theory we will study in next class. Thank you, children.